Okay, due to some technical problem, the net is not available. So that is the reason I have sent another link. So see here. So what is we are discussing the VI characteristics of SCR. So the VI characteristics of SCR, the forward blocking mode and conduction mode and reverse blocking mode. The forward bias mode we have two modes: forward blocking mode and forward conduction mode. And the reverse bias we have a one mode you can call as a reverse blocking mode, major mode. Okay, so in the forward bias mode, in the first one is forward blocking mode. So the region which is O to M of the VI characteristics, if you see this characteristics O to M, you can call as a forward blocking mode. We have here some leakage current, small few milliamperes of current is flowing, and it is negligible actually. So the at that region you can call as a forward blocking mode. And you have seen forward conduction mode we are discussing. So what is that forward conduction mode means? If the anode to cathode voltage is positive, as well as you have to apply some gate pulse. Okay. So applying a gate pulse, you have then the SCR starts to conduct. That means it is turned on. Either it is the first way of turning on the SCR. Another way of doing in the forward bias mode is you have to increase the forward breakover voltage. So anode to cathode voltage, you have to increase the voltage greater than forward breakover voltage. Then it is also turn on the SCR. But what is the thing is here present is you should not use the more forward breakover voltage. If you are goes on increasing forward breakover voltage, that is anode to cathode voltage greater than the forward breakover voltage, what will happen? It will destroy the device. That means SCR will burn. So the more and more current will flow in the circuit and it will destroy. So that is the reason most of the times you should not use to second criteria to turn on the SCR. That is, you should not use more breakover voltage, the anode to cathode voltage greater than breakover voltage. You should apply a positive gate pulse to the gate to cathode voltage only. Okay, that is the only thing you have to do in the SCR to turn on SCR. Okay, is it clear? In the thyristor family devices, you should not increase forward breakover voltage. The anode to cathode voltage should not increase greater than the forward breakover voltage. and that is, if you are increasing more and more for this anode to cathode voltage greater than the forward breaker voltage, it will destroy the device. Okay, what will happen in the VI characteristics? You can see N to K you can call as a forward conduction mode or on state. Why it is on state means it is behaves like a closed switch. It is behaves like a closed switch. The voltage drop across the thyristor in the state of the on state is order of 1 to 2 volts depending on the rating of a thyristor. The small voltage drop Vt across the device is due to ohmic drop in the 4 layers. So the voltage drop increases slightly with increase in the anode current. When the thyristor conducts, it behaves like a conducting diode and there is no control over the device. The anode current of thyristor is limited by an external impedance or load. Okay, is it clear? So if you see it in the forward conduction mode, you are increasing the gate to gate voltage and it will goes on increasing the gate voltage. So it will turn on. Okay, a gate current or gate voltage, either of them. So gate voltage or gate current if you are increasing, so it will turn on quickly and it is goes into forward conduction mode. And after getting into forward conduction mode, even if you are taking back the gate pulse, also it stays in the conduction mode only. Okay, there is no control, there is no gate control over the device after the taking into forward conduction mode. This is important here. Okay, so what is the important point here? Even you after conducting mode, it is goes into forward conduction mode. Even you take back the gate voltage or gate pulse or gate terminals, then there is no effect on the conduction. It stays in the conduction mode. And you can important terms, so you can also seen here is IL and IH. So what is IL? You can call, what is IL here? So here IL, latching current. So here you can call as a holding current. So what is a holding current and latching current? So what is the definition of latching current is the minimum forward current that flows through the SCR to keep it in forward conduction mode or on state at the time of triggering. You can call as a latching current. It is in the order of 10 to 50 milliamperes. So, and a forward current is less than the latching current, then SCR doesn't turn on. Is it clear? So, what is the latching current? It is the minimum current. What is the minimum current? It is the minimum current that it is able to turn on the SCR. That means it able to conduct in forward conduction mode, and it is in the order of 10 to 15 milliamperes. Okay, so and the gate pulse width should be chosen to ensure that the anode current rises above the latching current IL. Correct or not? So in order to latching current definition means it is a minimum current to latch the device. That means it is goes into forward conduction mode, and it is in the order of 10 to 15 milliamperes. And latching current will ensure the gate pulse width of the, you can get pulse with whatever you are giving by the externally. That means the gate pulse width should be greater than the latching current IL. Okay, holding current is, it is defined as the minimum value of anode current that below which SCR is gets turned off. Very important it is. So what is the latching current? It is the minimum current above which the SCR is turned on. So holding current is, so it is the minimum current at which the anode current is get turned off, below which the SCR gets turned off. Very important here. The above means latching current, below means it is below means below means below means holding current. Okay, so in the above which the SCR turn on is called as a latching current, below which SCR is turn off is called a holding current. So and IL is greater than IH, always IL is greater than IH. Okay, latching current is greater than holding current. Okay, see here characteristics also you can see. The latching current is here, holding current is here. So holding current is here and latching current is here. So IL should be greater than IH. So IL means it is for the turn on process. IH is for the turn off process. So the term IL is used in the turn on process. IH is the process of turn off in SCR. Okay. Is it clear? Latching current as well as holding current in the forward conduction mode. So next we have reverse blocking mode. So whenever the cathode is higher potential compared to the anode, so then what will happen? It goes into reverse bias. So and what will happen in the reverse bias? J1 and J3 are reverse biased and J2 is forward biased. Is it clear? So and cathode is made higher potential with respect to the anode and gate is open. Then it is the mode is you can call as a reverse bias mode. And the device behaves like a two diodes connected in series with the reverse voltage applied across them. So a small leakage current at the order of few milliamperes or few microamperes depending on the SCR rating will flow. Correct or not? Already discussed. What is that? The current will flow. A few milliamperes of current will flow in the reverse bias. That it is negligible also. So that is called a reverse leakage current or reverse saturation current or leakage current. In the diode you can call as a reverse saturation current. Here you can call as a leakage current, reverse leakage current. So in the reverse blocking mode, the state of SCR is off state. Correct? The state of the SCR is off because ideally it is off, but practically some current is flowing. So and the reverse blocking mode, it is treated as an open switch. Whereas in the forward conduction mode, you can treat it as a on state or an on switch. In the reverse blocking mode, you can call it is treated as an open switch or off switch. And after some time, if your reverse voltage it is increased, VR you can call as a reverse voltage. So that reverse voltage if increases more and more and greater than reverse breakdown voltage, VRBD, you can VRB or VRBD, this voltage is called VRBD, reverse breakdown voltage. Then what will happen? High amount of current is flows, high amount of current will flow in the device. That will also damage the device or the thyristor or SCR. So what is that you should not exceed this VRBD. You should not exceed this VRBD because if you are exceed this value, what will happen? It will more and more electron hole pair will generate and it will destroy the device or thyristor or SCR. So in the most of the cases, you should not use in this region. The SCR should not operate in this region. Okay, is it this region is okay, this region is okay, this region also okay, but you should not apply this region. Okay, and more than this VBA also should not use this voltage. Greater than this voltage also you should not apply because here also the device will burn. Here also the device will burn. Okay, or damage it will something happen. Okay, so this is the characteristics of the VI characteristics of your SCR. Is it clear, all of you? Is it okay? అందరికి అర్థమవుతుందా అమ్మా సుష్మిత స్నేహ క్యారెక్టరిస్టిక్స్ అర్థమైనాయా విఐ క్యారెక్టరిస్టిక్స్ Is it clear or not? Whether I explain again? Important. This topic is very important. Sindhuja.
Sir.
అర్థమైందామా ఈరోజు అప్పుడు చేస్తలేరేంది
ఎస్ సార్ కొంచెం
మళ్ళీ ఎక్స్ప్లెయిన్ చేయనా?
చెప్పండి సార్, ఒకసారి చెప్పండి మళ్ళీ.
ఓకే రైట్, అందరు వినండి కేర్ఫుల్గా. ఏమైనా డౌట్స్ ఉంటే అడగండి. మ్యూట్లో పెట్టుకొని ఆన్ చేసి మ్యూట్లో పెట్టుకుంటున్నారు అందరు నాకు తెలిసి, అందుకే ఎవరు సపోర్ట్ చేస్తలేడు. అది కాదు కదా ఇంపార్టెంట్ మనకు, తర్వాత మీరే అనుభవించాల్సి వస్తుంది. చూడండి, సో వాట్ ఈస్ హియర్? సో SCR is how many terminal device? It is a 3-terminal device. So and what is the speciality of the SCR compared to the diode? We have to apply a gate pulse, correct or not? So and how to apply this gate pulse? By external circuits. So VG and this resistor is the external circuit. So that circuit is connected through gate, and this also the SCR is also acts like a diode because it is also having rectifier operation. So what is the rectifier operation? It is a forward bias mode or a forward conduction mode. Here it will conduct. In the reverse bias mode it will not conduct. That means in the forward conduction mode it is on state. In the reverse conduction mode it is off state. That is on switch and off switch. So how to connect this forward bias means you know very well. So anode voltage is positive and cathode voltage is negative. So it is forward bias mode. And the forward bias mode we have a 2 modes of operation. What are they? Forward blocking mode and forward conduction. And what is the reverse bias mode? You have to connect anode to negative and cathode to positive. And okay, so in the and how many modes of operation is there? SCR reverse blocking mode, only one operation. Also actually we reverse breakdown region also be there, but in the reverse breakdown region you should not operate the SCR. Okay, because if you are operating this region means it is damage the whole device, there is no purpose. So that is the reason they have mentioned only 3 major or basic modes of operation. Okay, so these in this first mode, in the forward blocking mode, what will happen? In the forward blocking mode what will happen? So some leakage current it is flowing, some only few milliamperes of current will flow. How much time it will flow? Below the forward breaker voltage it will flow. Okay, and this after reaching this voltage it will conduct negatively. So negative characteristics, that means even the voltage increases current will decrease. But if you are you want to able to turn on quickly, you want to able to turn on quickly the device, that is on the SCR, you should apply a gate pulse, very high amount of current. The gate current should be more, that means it will turn on quickly, the SCR will turn on. Low gate current means it will turn on slowly, it will take some delay. Okay, so in this forward blocking mode what will happen? A few leakage current, few milliamperes of current will flow. So next in the forward blocking mode, what is the conditions for the junctions J1 and J2? J1 and J3 are what will happen? They are forward biased and J2 is reverse biased. And then and it will act like a open switch. It will act like a open switch. Open switch means off state. So after reaching some VBO, then what will happen? It should goes into the forward conduction mode. How it will be goes into forward conduction mode means it will goes into forward conduction mode by making 2 cases. What are the 2 cases? First case is you have to apply a gate pulse externally. So anode to cathode voltage is positive and you have to apply a gate voltage. Then what will happen? It will goes into forward conduction mode. It is the first case. In the second case, how to goes into forward conduction mode means you also increase the anode to cathode voltage which is greater than VBO voltage. So and in the second case it is not, it is permissible, you should not use this second case. Why? Because more and more anode to cathode voltage increases greater than VBO, which should damage the device or SCR or thyristor. So second case you should not use. Okay, and that is the reason. And the first case is very much preferable. The first case, which is what is that? Anode to cathode voltage is positive and also what you have to apply small gate pulse. Okay, and then it should be goes into forward conduction mode. The forward conduction mode, so what will happen, it will having some voltage of, it is about 1 to 2 volts, and it is acts like a closed switch. Closed switch means on state. On state means you can apply, the conduction is conducting, the thyristor is conducting, the thyristor is on. Okay, thyristor is on, that means the device is activate, the device is activated. Okay, so, and in this forward conduction mode, we have two important definitions of currents. So, latching current and holding currents. So, what is meaning of, general meaning of latch means on, latch means on and on, hold means off, something like that. So what is the latching current means? It is the minimum current. It is the minimum forward current that is applied to the SCR, above which it will turn on. The SCR will turn on. So what is the holding current? It is the minimum required current which will, the SCR will, below which the SCR will turn off. Okay, latching current always tells the turn on process. The holding current always tells the turn off process. And the latching current is about 10 to 50 milliamperes. And the latching current is always greater than the holding current. Okay. And how much amount of gate pulse is given to the gate terminal will decide by the latching current. Okay, so that will have some glimpse of the your latching current as well as the holding current. IL should be greater than IH. And a reverse bias, only one mode of operation only we have to learn. What is the reverse blocking mode? Reverse breakdown mode also there, but you should not learn because it is in this region the SCR will not operate. You should not operate this region. So in the reverse blocking mode, what will happen? J1 and J3 are reverse biased and J2 is forward biased, so that overall effect is reverse biased. Overall effect is reverse biased means, so what will happen? It is acts like a off switch. It will act like a off switch. Okay, so in a reverse blocking mode, the SCR will off state. The reverse blocking mode treated as a open switch. In the reverse blocking mode, you can also treat it as a open switch. So if you are this voltage, that is, what is the voltage here? Reverse voltage. If the reverse voltage is increases to some voltage, you can call as a VBR or VRBD, reverse breakdown voltage. So that reaches to that voltage, what will happen? Large amount of current will flow in the circuit that are divided by thyristor. So that will damage the device. Okay. So PQ region, the region PQ you can call as a reverse breakdown. So in this reverse breakdown should not operate, and because of the what is the reason? Because of large amount of excess amount of current will flow in this region. Okay, the O to P you can call as a reverse blocking mode, P to Q you can reverse breakdown, and this is leakage current, this is also leakage current. The forward leakage current, this is reverse leakage current. Okay, so this is the thyristor characteristics. Thyristor characteristics or SCR characteristics. Okay, so you should learn this characteristics, is very important. Okay, all of you. So I will wind up here VI characteristics because it is very important. You should learn very well in the next class. Then only you will understood very well in the next terms of the this device: turn on time, turn off time, holding time, latching time, like this, holding current, latching current, gate current, di by dt rating, dv by dt rating. Everything you have to learn in the next class. Okay. Is it clear?
Yes, sir.
So, ఇది నేర్చుకున్నామా మీ VI characteristics చాలా important. Next class we will learn about the other definitions. Thank you all.